Hello everyone, welcome back to Quest Zero. Today we look into the second problem or numerical on projection of lines. The problem states as a line PQ measures 80 mm in length. The point P is above HP and in front of VP by 20 mm and 30 mm respectively. The distance between the end projectors is 50 mm. The line is inclined to VP by 30 degrees. Draw the projections of the line and specify its true inclinations. So, this is slightly different from the problem that we had solved before. The very first thing that I need to do is draw the XY line. With your HP pencil and applying normal pressure, draw the XY line, name it with a 2B pencil. X, Y, the space above is VP, the space below is HP, since we are dealing with first angle of projections. Okay. The next thing that I need to do is mark the point P in both the front view as well as the top view. He says that it is 20 mm above HP and 30 mm in front of VP. So 20 mm above HP. So let me draw the line. 20 mm above HP and 30 mm in front of VP. With a 2H pencil preferably, or your HB pencil very lightly, or use a 2H pencil, that is better. At the ends, and to mark the point, dimension this. With a 2H pencil preferably, or your HP pencil, applying very light pressure. Fill arrow marks. Three is to 1 ratio. Dimension represented with a 2B pencil, 20 and 30. Naming point P is represented in the front view as P dash. Small p dash, this is small p. Next, we have only the inclination with respect to HP. The line is inclined to VP by 30 degrees. Okay, it is inclined to VP by 30 degrees. We don't know how much it is inclined with respect to HP, but we do have the value for distance between the end projectors. So what are end projectors? Suppose if you consider this as your line which gets projected, if I keep the pencil on one end, okay, and the other pencil on the other end, the projectors are nothing but the lines that you draw in order to project the endpoints of the line onto the projection plane. Considering the sheet of paper as the projection plane and the pencils as the lines which are drawn from the ends of the line to the projection plane, then the distance between the two pencils, it is your distance between the two projectors. Suppose now the scale is, or the edge of the scale is parallel to the sheet of paper or the projection plane. Now if I give an inclination to the scale and if I try to draw the projector, now the distance between the projector has decreased than what it was before. Now if I give further inclination, then this distance is still less. So it keeps on lessening as it tends to achieve the point location. Now what he says in the question is the distance between the end projectors of the line is 50 mm. So I'll measure 50 mm on the XY line. On the XY line, I'll measure 50 mm and I'll draw a vertical line with a 2H pencil or an HB pencil very lightly to sufficiently long distance. There is no measurement for this line. I'll draw it sufficiently long on both ends of XY. So this P dash P, the line collecting P and P dash, is one of our end projectors. The other end projector is now 50 mm from this. This line will fall on Q dash. Okay. So I'll name or mark the distance as well. Light lines, filled arrows, representation of the dimension using a 2B pencil, 50. Since all the dimensions will be denoted using the millimeter, we're not going to represent mm there. Generally, in any technical drawing, at the bottom, we do mention that all dimensions are in mm. But from the first angle projection of view and the common notations that are being used in the universities, we'll go with only the dimensions. Okay. Now, he says the line is inclined to VP by 30 degrees. So, to VP, again, I'll mark the locus at point P dash and P respectively, both P dash and P. The locus, as discussed, will be a longer line followed by a very short line. That is the line that we use to represent the locus. Longer line followed by a shorter line, longer line, shorter line. Okay. And again, there is no specified dimension for the length, but I'll try to draw it sufficiently long so that I need not have to redraw the locus or extend the locus while formulating the solution. Now, he says that the line is inclined at 30 degrees to VP. So, inclination to VP 30 degrees. using the protractor, placing the intersection of 0 degree and 90 degree line on the point P and making the 0 degree line coincident on the locus 30 degree, and on this 30 degree line I'm going to draw the true length of the line using 2H pencil or HP pencil, and it should be written very lightly using HP pencil. Okay, so let me denote the angle of this. It is 30 degrees. Let me call this point as, cross check once again. Okay, it is a little short as expected. So this point I'll name it as B2. Okay, and I'll draw a locus at B2. Let me use the other edge of the scale. The locus should always be parallel to your XY line. Sufficiently long. Now, if you observe the end projector that we have drawn, as I told you before, it represents the position of Q dash and Q, and the intersection of B2 locus with the intersection of the end projector line, or the distance between the end projector line, that gives me the position of B. This point is going to be B. Now it is PQ. Okay, we are using the notations PQ, unlike AB in the previous problem. Let me erase this. This is Q2. Okay. This is Q2, small q2. This is Q. Joining P and Q will give me the, with a 2B pencil, dark, it represents the top view of the line asked in the question. Now, once the top view is determined, we need to now obtain the front view of the line. So this is 80 mm line. I'll mark it with 2 cross lines to say that it is the true length of the projection. Now, I need to now from Q2, let me draw a vertical line until it intersects the P dash locus drawn at P dash lightly with a HB pencil or a 2H pencil. I'm drawing the direction. Now we'll use the same method that we had done before. This point is Q2 dash. Using your compass, keeping the needle end at P dash and your pencil end at Q2 dash. Okay, with the radius P dash Q2 dash, draw an arc until it intersects the projection end projector line. So I need to extend the end projector line further, the 50 mm distance from PP dash. I'm going to extend it a little further. Now this is the point where the arc and the end projector intersects. That the point is a required point Q dash. Now connect P dash Q dash. To obtain the projection of the line in the front view. And he says specify the true inclination with HP. Now the inclination that is present now is the apparent inclination. This is the apparent inclination alpha. This is the apparent inclination beta. PQ inclination with respect to XY line is beta. P dash Q dash with respect to XY is alpha. Now he says the true inclination with respect to HP. Now the true inclination with respect to VP was given in the question as 30 degrees. So we have retained it. Now we need to find out the true inclination with respect to HP. So in order to obtain that, I need to draw the locus for Q dash. At Q dash, draw a locus parallel to your XY line, sufficiently long. Okay. And from P dash, I need to draw a line which is equal to the true length 80 mm. So what I'll do is, you can proceed with two ways. The first method is taking P as the center and Q as the other end of your compass, or keeping P as the center of rotation and PQ as the radius. Draw an arc until it intersects the locus at P. Until it intersects the locus at P. Okay, this is the reverse method of what the problem we had solved before. Okay, and from this point, let me call it as Q1 dash. Sorry, Q1. Okay, this is Q1, the intersection of PQ radius with P as center until the locus of P. That I'll call it as Q1. And from Q1, I'll draw a vertical line which intersects the locus at Q dash with your 2H pencil or your HB pencil very lightly. Okay. This point is Q1 dash. and the line that connects P dash and Q1 dash is the true length in the front view, and the inclination that you get is the inclination with respect to HP. So if you even measure, the distance is still going to be 8 mm. So with your 2H pencil, draw the line, draw two lines on it to say that it is a true length line. Okay, this is one method. The other direct approach is you can measure 80 mm on your scale or take the true length measurement from the top view. From P dash, cut an arc and it will be at the same location. Cut an arc from P as center and the arc should intersect the locus at Q dash. That will also give you the same position, Q1 dash. Okay, both are okay. Now we need to find the angle at which the inclination is with respect to HP. So if I draw or take the measurement, the inclination turns out to be 37 degrees. Okay, I'm going to mark this inclination, which is the required inclination, as 37 degrees. And to make you accustomed with the other measurements, this PQ measures 6.5. or 65 mm with your 2H pencil. Filled arrow marks 65, and the one in the top view, front view, it measures 6.7 or 67 mm. Okay, this is 67 with a 2B pencil. The alpha angle is the angle between P dash, Q dash and XY line, turns out to be 44 degrees. So this angle is 44. This alpha, and beta is 38 or 37 degrees. So beta is 37 degrees. The arrow marks on the arc should also be at 3:1 ratio. This is 37 degrees, it's nothing but beta. So as per the question asked, the true inclination of line with HP is equal to 37 degrees. This 37. Okay. So this completes the solution for the second numerical on projection of lines. Do like, subscribe, and share amongst your friends. We'll come up with a new problem in the next class on projection of lines itself. Thank you.